Cast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and thanks for joining today's webinar. We will get started on time in 4 minutes. Good morning, everyone, and thanks for joining us for today's webinar entitled Transforming Drainage, Managing Water Quality to Improve Crop Yields and Water Quality. My name is Anna Goodjohnsdottir, and I'm the project coordinator at the Partnership for Ag Resource Management, who's hosting the webinar this morning. We are joined today by my colleague, Dr. Thomas Green, president and co-founder of the IPM Institute, who will provide a brief introduction. I'm also pleased to welcome our guest speakers. Today, we will hear from Dr. Jane Frankenberger, Professor of Agricultural and Biological Engineering at Purdue University, and Charlie Schafer, President and owner of AgriDrain Corporation. At the end of their presentations, we will use the remaining time for Q&A. So before we begin, I want to share some brief logistics. You will remain muted as an audience member during the presentations, but please make use of the question box on your screen to type questions for Jane and Charlie. I will moderate the questions at the end of the presentation. This webinar is being recorded and will be available later on partnershipfarm.org. By attending the webinar today, you are eligible for 1.5 CCA continuing education units, 0.5 for nutrient management, and 1 for soil and water management. You must be present for the entire webinar to receive those points. If you are watching this webinar live, you will receive an email in the next few hours with the webinar recording and a link to submit survey evaluations. A link and pop-up question will be provided at the end of this webinar to submit CCA credentials to earn points if you've not already done so. If you are watching this on demand at a later date, please be sure to watch through the Citrix platform and not through YouTube to receive credit. A link to register on Citrix will be provided in the text below the YouTube video recording, or it will be emailed to you if you've already registered for this webinar. You are provided instructions at the end of this presentation to submit your credentials. And now with those logistics taken care of, I will turn it over to Dr. Thomas Green.
Thanks, Anna. How's my volume?
It's good.
Great. Thanks, everybody, for joining us today. Partnership for Ag Resource Management is one of the many projects at our nonprofit IPM Institute, each focused on using the power of the marketplace to improve sustainability. Go ahead and advance here till we get all of the images on the slide there, Anna. So our team of 20 is currently working to increase adoption of best practices and improve outcomes in health, environment, and economics, all key elements of sustainability. We work with pest control companies, hospitals, schools, and other facilities and communities, and with food companies and farmers around the world to improve practices, performance, and to communicate those benefits to buyers and the public. Next slide. We write regularly on IPM and other topics for Crops and Soils magazine. Our article on BT corn is in the most recent issue. Certified crop advisors can earn 1 CEU by reading the article and taking the quiz. Next slide. So our objectives with the Partnership for Ag Resource Management are to identify revenue opportunities for ag retailers that help keep our valuable ag resources on cropland, to help promote those products and services, and then track sales through annual surveys and estimate reductions in losses of nutrients and other inputs that result from those sales. Then we report those sales data back to our participating ag retailers for their location and compare those to state and regional averages. We work with ag retailers and industry associations to publicize these great accomplishments through press releases, articles, and social media. It's very important to get this positive news out to address misperceptions the public has about agriculture. Next slide. So our upcoming survey will include ag retail products and services that address keeping both nitrogen and phosphorus on cropland. However, to date, we focused on phosphorus losses. These two photos on the right show what happens when too much phosphorus gets into water, feeding blooms of harmful algae which close beaches to swimming, make fishing a challenge, and have also shut down public water supplies. The graph on the left shows NOAA annual data on algal bloom severity since 2002. After phosphorus loadings declined sharply in the mid-80s with the advent of reduced tillage, they've increased, and as a result, we experience more frequent and severe algal blooms. And as you can see, 2017 was up there, the fourth highest in recent years, and that's no surprise given the weather conditions we had this past year. So the timing of the phosphorus runoff and losses through child drains and impacts on algal blooms is highly dependent on weather. And we know that the phosphorus is coming primarily from agriculture because of the timing of the loads. They spike during snowmelt and rain events in winter and early spring following fall surface applications. Next slide. Ag retailers have valuable products and services which can keep inputs on cropland and out of waterways. Here's a list of some of those for phosphorus retention and use efficiency, along with some very rough average reductions in losses based on published studies. There's lots of variability in the published numbers based on soil type, slope, proximity to surface water, and other factors, but these rough averages give us a sense of where we can likely make a difference. Cover crop, soil testing, grid or zone sampling, variable rate application, custom application are revenue generating opportunities that also reduce phosphorus losses. Ag retailers can also let farmers know when a broadcast application has been made so they can get out there and get the application covered, can avoid application before a heavy rain event, abide by setbacks, and let farmers know when you see an issue that needs attention, like a tile drain blowout. Applying only enough phosphorus for the following crop rather than the next several crops in the rotation can also reduce losses. So today we'll hear from experts about controlling water movement from cropland soil and the nutrients that move along with it. This will be a foundation introduction to controlled drainage. It's important that everyone working with farmers understand the systems and the benefits, and also the impacts on agronomic decisions. And we'll plan to follow up with a second webinar focusing on how to optimize recommendations for drainage-controlled fields. Next slide. So ag retailers are making a difference. For example, our annual surveys show large increases in variable rate phosphorus application. In the Sandusky River watershed, they increased from 17% of acres serviced in 2011 to 70% last year. That's an incredible increase. In 2015, we secured funding for ag retailers to offer a discount on variable rate to farmers in the Sandusky and other watersheds who had not used it before. We've had nearly 40 ag retailer locations participate. Using published estimates, acres of VRT here alone represent more than 1 million pounds of phosphorus prevented from leaving cropland in the watershed. So we need to track and report these improvements we're making so that regulators, policymakers, and the public are aware of these voluntary efforts, using the power of the marketplace to drive improvements. You'll hear more from Anna about some of the tools and resources we have for use as we work to achieve these goals. And with that, I'd like to turn it back to Anna.
Thanks, Tom. As Tom mentioned, we do have some free resources available on our website, partnershipfarm.org. On the left, you can see the front page of our newly updated agronomist handbook that is available free for download. The update includes a new introduction and additional fact sheets that you can provide to growers to increase awareness of products and services that reduce the export of nutrients from cropland. On the right, you can see the front and back of our phosphorus loss reduction wallet card, which can be ordered for free on our website as well. These serve as a great conversation starter with your growers, and many people order them and take them to their various meetings. To date, we have distributed more than 25,000 wallet cards. So our next webinar will be held towards the beginning of January, but the date and time are to be determined. Thanks to funding from the EPA Great Lakes Restoration Initiative, we are still enrolling growers in the Sandusky, Cedar Portage, Lower Maumee, and Blanchard watersheds in Ohio for our VRT cost share program. If you are interested in learning more about VRT or possibly getting involved in the program, please contact Mark Adelsberger for more information. We would also like to announce that our 2017 Great Lakes Ag Retailer Products and Services Survey will be distributed next week, and a link to participate will be emailed at its release. The survey allows us to track ag retailer sales of products and services that keep ag inputs on cropland and out of the Great Lakes. By selling valuable products and services, including soil sampling, precision ag, and cover crops, ag retailers are making a difference. The information we report back to you is critically important for our industry to communicate to our customers, community members, shareholders, and regulators. It's also incredibly valuable to document your own stewardship in the ag retailer community and what you are doing to voluntarily help solve our water quality problems without additional regulations. We thank you in advance for your participation. And finally, we would invite you to follow us on Facebook and Twitter for PARM updates and industry news. Look us up from your computer or mobile device after the webinar. Now we'll hear from Dr. Jane Frankenberger, Professor of Agricultural and Biological Engineering at Purdue University.
Thanks. I guess I didn't have the choice of which screen to take, Anna. I'm sorry. Hello, everyone. I was expecting, do you see my slideshow correctly or the whole?
Yeah, if you could just hit begin presentation.
Shoot, we did this. New screen, now show screen.
It should be the button.
Okay, here we go.
Yeah.
Okay. Thank you. Now, is it showing the slideshow view?
No, it's not.
Oh, great.
Oh, there it is.
Should have practiced again.
Yep.
There it is, the slideshow view?
Mm-hmm.
All right, hello everyone. Obviously, GoToWebinar is not something I use a lot, but I'm very pleased to join you today on the webinar from Purdue University in Indiana, where I'm a professor and also extension specialist working particularly on agricultural water management. I'm going to start by giving you an overview of why we're looking at the new practices that transform drainage and what they're showing, what the research is showing. And then Charlie Schafer is going to follow up with talking about how these are actually implemented, especially in the private sector. So certainly excess water is the most common agricultural water management issue that we address. As I'm sure you all know, problems of excess water are well known. Here's a cornfield and here's a soybean field showing ponded water, which obviously they don't like and can reduce yield if it lasts too long. And the excess water is particularly a problem when spring field work is not yet done, as it makes it difficult to get into the fields. So as also, I'm sure you know, to maximize production, subsurface or tile drains are installed throughout much of our landscape in the Great Lakes region. And this shows the installation of perforated tubing, also known as tiles, at the only time that people can see it, which is when it's being installed there. And land improvement contractors throughout the region install this tile drainage efficiently and effectively. And as a result, we've got this very extensive drainage infrastructure that's under most of our land. They're buried 3 or 4 feet deep, providing a plumbing network that's out of sight and out of mind, but it makes a tremendous difference in the productivity of our poorly drained soils. I thought I'd just show this quick little animation to show what drains do if any of you are less familiar. So as the rain falls, it infiltrates into the soil and it raises the water table, which is the zone where soil is saturated, into the root zone, which is obviously can be harmful. And the tile drains provide an outlet for the water that lowers the water table to keep the roots healthy. So we've got this great infrastructure. Again, it's extensive, it's very efficient, and it removes water year after year. We've got the subsurface tiles and we've got the surface drains. So what's the issue? Why are we talking about something as grand as transforming drainage? So before I talk about the transformations that we're trying to bring about, let me raise the 2 issues that work together to point towards the same kinds of solutions. The first is that nutrient loss from tile drainage is causing issues of national concern. In the introduction, you saw a little about the phosphorus loss. Tile drains are certainly the broadest source of nitrate in streams. More recent research is showing more clearly that they're also a major pathway for phosphorus. And I just have one photo here that's similar to what was shown before about Lake Erie. Now, I'm not going to go into detail on how phosphorus gets into tile drains, but it is important for everyone to understand that it does. If you went to school a few decades ago, like me, you probably learned that phosphorus moves primarily with soil as it erodes, and that was the best understanding at the time. But as like so many things, science continues to advance, and we understand better and better that a lot of the phosphorus that's getting into Lake Erie and other lakes and streams actually has moved through the tile drains. So it takes slightly different solutions than may be used in areas where there's more slope and there's not tile drains. So that's one of the issues. The other one is that even though I've shown a lot of pictures of wet soil, and we do have that excess water in the spring, we actually have slightly reduced yields often by lack of water in late summer. We don't typically have droughts, but even in good years, there often could be a little yield bump if there was more water. And once in a while, there is a major drought. For example, just for Indiana, this shows the payments by federal crop insurance for 25 years. Here's what's from flooding and excess moisture, and here's what's from drought. So, of course, that was mostly from 2012, when the severe drought reminded many people of our potential for having too little water as well. 2015 is another year that particularly reminded us of the problem. In June, here's an Indiana field in June and a field in July. We followed too much by too little water, and this reminds us that having too much and too little water can even happen in the same year. So we've got these two issues again. First of all, that the excess nutrients in spring causing water quality problems, and the lack of water availability. Both are not expected to get better in the future, but are in fact expected to get worse. There will be more, when it's wet, it'll be wetter, and when it's dry, it will be even drier. So now we move to the solution. What do we do when we have sometimes too much of something and sometimes too little? It points towards a storage kind of solution. So this is what we're thinking about. How can more of the water be retained in the landscape? And that's the focus of a large project that scientists like me from 8 states, actually 9, are working on to talk about managing water for tomorrow's agriculture, that we need to actually look at storage or retention of water in the landscape. So though our goal has been to get rid of the excess water as quickly as possible, we want to move to a different goal where we could instead store water. But the question is, how can we store water? Our landscapes are full. They're full of cropped fields and towns and ditches and everything. So we have to look at the landscape and think where we could store water. Could we store some water in the field? Could we store it in the buffer? Because many of our fields at least have a small buffer. Can we actually store more in the ditch or downstream? So that's what I'm going to talk about for the rest of the time, of practices that are being developed by scientists and engineers and tried by some innovative farmers that actually can store more of our water to address future water management challenges. One way that you've probably heard of, because there's a lot of talk these days, is soil health. Can we store more water in the soil by increasing soil health? And there is a certain potential for that. This is an NRCS graphic that suggests every 1% increase in organic matter it can add as much as 25,000 gallons of available soil water. So we don't know the exact number, but there is certainly an increase possible. So that's one way that a certain amount can be added, but 25,000 gallons isn't nearly enough, unfortunately. So we need to look at other ways. Another place that we can store excess water is in the ditches, and in Ohio, Indiana, and elsewhere, there's been a move to widen our ditches to be something called a 2-stage ditch, which, as you see here, actually has the channel stays the same, but then benches are added so that there could be much more water storage, and it's another potential. But the ones I'm going to talk a little bit about more start here. We can actually change our drainage system to hold back more of the water, to store more of the water. And one of those practices is called controlled drainage or drainage water management. And what this means is that we install a water control structure in the tile drainage system. And after harvest, we put sort of a dam in the water, and it holds the water table higher. This can be removed before planting or harvest, anytime people need to get into the field, so then it just functions like a regular tile drain. And after planting, we have the potential to raise it up maybe a little less high so that it can actually add water for the crops. This is another graphic of the same practice, but it shows it from another perspective, that we put this control structure here in the tile system. We've got a piece of field here, and the water that would go down directly to the ditch is held here in the control structure, and it raises the whole water table. This practice works best on very flat fields. When we have a field that's not that flat, then we can add a second control structure, for example, and that will raise the water table again. So I know a lot of these structures have been installed in the Great Lakes, especially Ohio and Michigan, and there's a lot of potential as long as they are used to hold back the water and actually reduce the amount of nutrients that are lost. I work with, I conduct research in controlled drainage, and I work with people who do around the whole region. And so our results vary, but everywhere we've shown reduction in nitrate and phosphorus loss, sometimes more, sometimes less, but there is a reduction, and increases in crop yield. They're not big increases, but they are slight. It all depends on the hydrology during any given year. So it's one of those practices that has environmental and crop yield benefits. Another place that in the landscape that we potentially can store some water is in the buffer. Now, in certain areas have buffers and some don't, but people have gotten thinking that when there's a tile drain under the buffer system, it really isn't doing any good, at least for the water that flows through the tile drains. So could we take the water that would go to a conventional ditch with its nitrate and actually distribute it back into the buffer? So there's another tile line that's installed across the buffer so that the water flows out of the tile and into the buffer. This practice is particularly useful for nitrate, where a process called denitrification can really treat a lot of the nitrate. Unfortunately, it's not so useful for treating phosphorus because there's no equivalent process in the world of phosphorus that simply gets rid of water, but it does work for nitrate. But the third practice we think has a lot of potential, but really hasn't been tried that much yet, is actually storing water in ponds or reservoirs, which is shown conceptually here, where the drainage and surface runoff go into the reservoir and then are fed back onto the land, the cropland, through some kind of irrigation. I have this graphic here that shows that there's a lot of detail here, but basically it can be the drainage comes out, goes into the pond, and it can be fed back onto the land through sub-irrigation, or it could be through sprinkler irrigation. So there's not only one type of irrigation that would work. What's important in this practice is that the tile drains, instead of flowing directly to the ditch, are held in, the water is held in a pond, so that water, the same water with all the nitrogen and phosphorus that are in it, go back onto the field. And that's why the term recycling is there. It's not recycling water from an urban area or anything like that. It's just the water that came out of the tile, full of good nutrients if they go on the land, and now they will be used by the crop rather than go downstream where they're very harmful. Now, this practice has potential, but it's certainly not very common yet. I think there's a lot of economics and other issues that need to be dealt with. But there are a few. Here's one pond in Michigan, where it's a raised pond, and here's the system for the pumping it in to the pond, and then also the intake for the irrigation system. As you are probably imagining, if you're thinking about it, these ponds would need to be very large, and that's true. They do need to be very large. Here's one that they were just digging in Michigan when I took this photo, and it was about 20 feet deep. So these are not small ponds by any means. It obviously takes some land out of production unless there's land that's not being used, but it has the potential to increase the yield on the remaining cropland. So what some of us have been thinking about is how can we fit more ponds into our landscape? Now, here's just a landscape around West Lafayette here, but it's not a landscape that's all alike. There are different places where potentially a pond could go. So when I first started thinking about this is driving across Ohio, where 24 was built, and there's all these borrow pits for road construction. Could they be used? And I think that, in fact, the first pond at this farm in Michigan was actually a borrow pit. There's sometimes stormwater ponds that we could use. Some people have thought about former lagoons that are no longer being used for livestock, or just a pond that's dug specifically for this purpose. So these are all possibilities. And that's what we're thinking about together, because it's a big idea. We need a big group of people thinking about it. There's a project called transformingdrainage.org that I lead. Charlie Schafer, your next speaker, is on the advisory committee, and all these universities shown here are involved. The actual name is Managing Water for Increased Resiliency of Drained Agricultural Landscape. So we're trying to advance both the goals of reducing the uncertainty and risk related to water availability. Remember, having too much water and then too little, and also reduce those nutrient losses from agricultural fields, which besides having environmental impacts, also represent money going downstream. So the practices with increased drainage storage are addressing both of those. So we have field research across the region that's looking at these, so all the way from North Dakota to North Carolina, but most of us are in the Great Lakes region, and we've got sites set up where we're measuring these practices, and we have 186 site years of data that are currently in a database, and now we're looking at how to synthesize those. So for example, for one site where I work, we've got nitrate data, and we can show how much reduction there is from controlled drainage, and then we're synthesizing it across all the sites. So I'm not going to talk about much research specifically here, but just that there's a large group of scientists that are working together to try and determine the potential benefits of these practices that store water in the landscape. And I'll just end by saying we're also very happy to get the word out. I'm happy to be on this webinar. We have a website called transformingdrainage.org. The name is the URL, and we highlight these practices and our various outputs. We've also put out publications together. For example, we've got one on drainage water recycling for the Midwest. And we have a lot of field days. People throughout the region are holding field days on these practices. And we also are very pleased to involve the private sector. So the Drainage Contractor magazine has talked about transforming drainage and these new drainage water storage practices. The Agricultural Drainage Management Coalition that Charlie Schafer leads, and probably we'll talk about in a minute. And we've got Iowa soybean and other commodity groups. So I think the agricultural retailers are a wonderful potential audience, but also actors to help in getting the word out about new drainage practices. Because to actually transform drainage, obviously it's a big task, not going to happen easily. And so we have the vision of that we all need to work together so that the process of designing and implementing agricultural drainage sometime in the future will be transformed so that we include water retention and even water recycling, so that the nutrients that are a disadvantage when they happen now and they just go straight into the ditch, but they can actually be used for their purpose to enhance crop growth. And that's what we hope will happen through these new drainage storage methods. So thanks. That's it. And I think we take questions after Charlie Schafer talks, right, Anna?
Yep, that's correct. Great. Well, thank you, Jane. So next we will hear from Charlie Schafer. Let's see. So Charlie Schafer is the president and owner of AgriDrain Corporation. And so I will turn the presentation over to him. Okay, great.
Are we ready to go?
Yep, your screen's on.
Great. Okay, thanks. Good morning, everybody. Thanks, Anna and Dr. Green, for the opportunity to participate here. And it's always a pleasure to listen to and learn from Dr. Frankenberger. The whole Land Grant University and Extension has been really supportive of the drainage industry, and it's been greatly appreciated. It's helped us move some of these concepts forward, so appreciate that. So some of this will be maybe some a little bit redundant. There's some review of what Jane's gone through, but I want to talk a little bit about how industry and our Ag Drainage Management Coalition has helped to advance some of these concepts and work in product development, but also practice development to think about how we more efficiently manage water, not just for agronomic benefits and crop production, but also for more of a multi-purpose water management approach. So we can take into account environmental, agronomic, even habitat, peak flow reductions for flood mitigation, lots of things like that, soil health. So with that, some of this I mentioned review. I assume all of you are familiar, most of you are familiar with why we install drain tile. And there's lots of reasons, but initially it was all about money. It was about making these saturated soils farmable to increase trafficability, encourage good deep root growth, less plant stress, but also the public health benefit of reducing surface and standing water where we'd have mosquitoes and issues associated with that, and even the ability to, did we?
Charlie?
Yes.
Dominique from Windstream Sales is online too.
Sorry, I'm on a conference call. Thank you.
Oh, I apologize.
Sorry. I'm at my desk, so I just got a call. I'll take it later. But anyway, I think everybody understands the benefits of a drainage tile, subsurface drainage. Jane talked a little bit about some of the crop loss and crop insurance payout. Here is a couple of graphs from Iowa for a couple different periods, about 55 years, that identifies corn yield potential loss due to too much or too little moisture. And we look at over 2/3 of the yield loss associated with those conditions, and also over half of the yield loss with soybeans. So it's really dramatic, the amount of impact that excess moisture and drought can have on these crop yields. And so as Jane mentioned, it can happen in the same year, too wet in the spring, too dry in the fall. So it's an issue that we can deal with proper water management. Here's a report that was done over 25 years in Ohio on yield, and it talks about corn and soybeans. I won't get too far into the weeds regarding return on investment, because many of the systems that are designed and installed, they vary greatly in cost depending on spacing and depth and soil types and things. But if you just look at return on investment with corn at 24 to 39% increase, that's an average of 36.5%. If we get back up to the $4 range on corn off 175 bushel yield average, you're looking at something around 64 bushels, over $250 per acre yield increase. And if you've got a $1,250 system, $1,250 per acre, you could easily achieve a 20% increase or return on investment there. It really becomes significant. In the past, we basically installed drains, surface and subsurface drains manually, but we like to note that they were still 24/7 gravity flow systems, and they flowed year-round whenever water was at or above the elevation of the flow line of the tile. industry got smarter about how to install these drains more quickly. We went to automation, mechanization, plastic tile. We used laser guidance, now GPS, GIS, high-speed semi-vertical chains. But still, the systems run 24/7, so we like to think we made them faster, easier, cheaper, longer useful life, and more intensive, but certainly no smarter. They still flow 24/7, which we're steering tractors and harvest equipment with satellites. We've got precision agriculture, but yet the drainage industry hasn't yet really embraced some of these concepts. So that's what this is all about. Through our association with the land-grant universities and the Ag Drainage Management Systems Task Force, we learned what we like to call the golden rule of drainage, and I guess we attribute this to Dr. Wayne Skaggs, North Carolina State University. He said, golden rule of drainage: drain only the amount of water necessary to ensure equipment access and healthy production, and not a drop more. And so what the Ag Drainage Management Systems Task Force told us way back in 2003, when we first started to meet with them, was that about half the water in the Corn Belt, across the Corn Belt, that leaves these subsurface drainage systems and farm fields leaves in the wintertime, when drainage isn't necessary during the fallow season. And so if we just install structures and manage these outflows, we can reduce the total nutrient transport, both nitrogen and phosphorus, by about 50% range. So it's really becomes significant. And so what Jane talked about was the installation of some type of structure, some means to control the elevation and flow rate of the water associated with these subsurface drainage systems. And so you can see from here, if we install a simple water level control structure where we can add and subtract stop logs to raise and lower the water level, and if we connect them to the main tile line where all the laterals are hooked into, then we can create zones of influence, and we can actually manage individual zones throughout the field to drain when is necessary and hold water back when we can, for the benefit of increased yield and or environmental benefits by reducing nutrient transport. And so if you think about a year-round schedule, you might consider in the spring we drain the fields down again to ensure trafficability, good deep root growth. We reduce compaction, we warm the soils. In the summer, once the roots are established and we're out of the field with field operations, then we would raise the water table a bit, maybe within 24 to 30 inches of the ground surface, in order to provide water and nutrients for those crops as they root down deeper in drier periods of time. In the fall, drain down again for harvest and field work, and then in the wintertime, again, we'd raise it back up to within 6 to 12 inches of the surface to store as much water and nutrients as possible. There are public and private benefits associated with drainage water management. You can see we reduce 30 to 60%. We like to think about a ballpark of 50. It varies depending on site conditions, rainfall patterns, and things like that. But all the things that Jane talked about, even additionally liquid animal waste when it's applied to farm fields that are artificially drained. So there's lots of benefits that we can get from that. Here's some interesting statistics from North Carolina State University about some yield enhancement that was achieved just with holding water back during the growing season. And so again, depending on rainfall patterns, we had some pretty significant increases at a very, very low cost to the producer or landowners. So those can be significant. We recognize that these producers want to do the right thing environmentally, but they also need to have an incentive or motivation to do it, and typically that's driven by financial concerns. So we think about a sense of urgency, maybe not this urgent, but yet if we allow farm fields to continue to be drained as they currently are without consideration of specific designs that could allow us the opportunity to manage these systems, we really miss an opportunity. And these systems are so long life, they can last 100 years. So if we like to think that if all the farm fields were as flat as a pancake, that it really wouldn't matter how you designed a subsurface drainage system. because you could still go to that outlet and you could still install a manual or automatic water level control structure at the outlet, and you could add stop logs to raise the water table in the soil profile, and you uniformly affect that whole field because it is flat and water seeks that flat level, but fields aren't all flat. There's typically some slope involved upstream to downstream, and so we need to think about the design consideration as we lay these things out prior to installation. And so if we put our main tile line, the collector line, at the bottom of the slope, and we run, which is typically how it's been done in the past, run our lateral lines downslope and connect them to that main line, and we install a water level control structure at the outlet, then we only affect a small area at the lower portion of this field. And so it does not give us the opportunity to fully take advantage of the opportunity to reduce nutrient transport and increase yield. And so if we think about this prior to design and installation, and we install our main line up the slope, and we install water level control structures or some device to manage the water level and flow rates at every foot of elevation or grade change, then we can affect change through the entire field up through the slopes, and we create zones of influence with each individual structure. And so that allows us the opportunity to manage a much larger portion of that land mass, that field area. We like to think that this is a pretty simple concept. This is not rocket science. It's not a picture of me, but it's something for just to make the point that it's a pretty simple process. If we add and subtract stop logs to raise and lower the water level, depending on time of year, type of crop, then we can make a significant difference in total overall outflow and nutrient transport. One thing that we've done through the ADMC, with help from Natural Resource Conservation Service through a Conservation Innovation Grant, and working with the Ag Drainage Management Systems Task Force, was to do a demonstration project in Minnesota, Iowa, Illinois, Indiana, and Ohio to go from plot scale research work to field scale paired systems, to actually design systems where we'd have a control on one side that was traditional gravity flow 24/7 system and 20 to 40 acre fields, and then side by side with similar soil types, same planting dates, same cropping methods, we'd have a managed system with drainage water management, and we kept track and recorded and monitored water levels and flow rates. We looked at yield enhancement, we looked at nutrient transport, and then other things that could be unintended consequences, even down to things like earthworm counts and things, and soil structure, the soil profile, to make sure that we weren't doing creating any negative impact. This was let's see, okay, here's an example of a paired system that we studied in Indiana, and it shows how the systems were designed and installed, how we managed these systems, and then we took the results from this, took it back to NRCS after the study, and from that, NRCS did a conservation effects assessment project, whereas they determined that the environmental benefit associated with the practice of drainage water management was significant enough that they could actually provide EQIP funding for this practice. And so not only do they fund the structures, the submains, and the management of these things, they actually financially provide compensation for the creation of the conservation activity plans, so the design on new or retrofitted systems. And these are just examples of Iowa, for instance, that they do for the conservation activity plan, the management of that, the structures themselves, and the surface drains if you need to add additional drainage to these systems for submains or things to include more acres in those zones of influence. So that's significant, and it's very helpful that we can utilize these technical resources and financial. Another thing that the Ag Drainage Management Systems Task Force has done, in addition to these demonstration projects, is also worked through NRCS and worked with the land-grant universities to provide technical service provider training for over 130 contractors to actually go out and work with landowners to design these systems, and then since they're registered with and certified by NRCS, they're qualified to receive compensation, financial assistance for the plans. So that's a significant step forward in promoting the adoption of these types of practices. When you've designed a system that you can manage and passively sub-irrigate by providing moisture to the crops during the growing season, you also have a system that you have the opportunity to actually convert to a sub-irrigation system by utilizing an external water source, either surface water, like Jane talked about, or subsurface through a well. And so basically you just reverse the drainage process by adding water back into the drainage system and raise water up into the soil profile to provide additional water to the crops. We find, and research has proven, that this type of a sub-irrigation system compared to a conventional overhead pivot irrigation system can be something in the range of 50% less energy and water required, because there's no evaporation and certainly no runoff. So this is something we've utilized for a number of years. It's been done for over 20 years in some states, and we're seeing more and more adoption for this as well. The small light colored green kind of pipe barrel type devices you see there, rather than the full height water level control structures, are what we call water gates. We'll talk about products in a little bit too, about the things we manufacture and distribute that can create these agronomic and environmental benefits. So with a sub-irrigation system, that really allows us the opportunity to think about a perfect world scenario and consider, if we have the option, how would we manage this water to provide the greatest potential environmental and agronomic benefits. And you'd think about the crop, the planting date, depth of roots, need for water at specific points during the growing season, and you can establish set points through automation and or the addition and subtraction of the stop logs to raise and lower the water level, because now you have a source, you can add it right in. So you really have a perfect world scenario. Oftentimes contractors or landowners, farmers will ask me, what kind of yield enhancement should I expect from a subsurface drainage system that's capable of sub-irrigation? And what I normally tell them is that think about the best field you have that's intensively drained, and think about the very best yield you've ever gotten off that field. And they do, they remember it, they think back, and then say, okay, imagine getting that type of water management, perfect world scenario every year, but also consider the potential of increasing your plant population and your fertilization rates, all your inputs, based on the confidence level you have that you're going to escape from those negative impact events like too much or too little water. So now you can manage it. So you've got a field out there that is really capable of performing at peak level every year, and so you can comfortably invest those extra dollars into that production unit to increase yield even beyond what you've experienced in the past. So it's a pretty exciting opportunity, and people can visualize that and understand how that can make a huge difference in their operation and reduce risk. Some things you think about as you work with your growers, your landowners, think about some of the site selection issues that you want to consider. You'll drive past fields, I do it all the time, and take a look and think, man, that would be perfect for sub-irrigation. It's flat. I've got either maybe a pond upstream, or you'll see a power nearby where you can drill a well. And so you must consider that the soils do have a barrier below them. That's why they need drainage in the first place, because they tend to hold water. They're poorly drained. You have the slope that's flat enough that it's not terribly expensive to install these control structures and these devices. This practice can be applied to steep fields and rolling fields, but from a design standpoint, it's more difficult, and from an installation and bill of material standpoint, it's more expensive. And so oftentimes we'll tell people that it may not make sense for them. They may not get the kind of return on investment that they really expect or want to have. So those are some of the site considerations. We developed then through the company Ecosystem Services Exchange, which I founded a number of years back. They are technical service providers to NRCS as well, and they do design and technical assistance work on a variety of practices, but primarily drainage, water management, and sub-irrigation plans. We recognize with AgriDrain Corp, we can provide these widget-based solutions to agronomic and environmental issues, but unless those landowners or contractors have the technical assistance to design these systems, they may not take that leap and try to step up and figure it out on their own, or try to make all those decisions and maybe make some mistakes. So you see on the lower right hand corner, the sub-irrigation plan, Ecosystem Services Exchange provides that service to them. So we can lay out and design these things based on, again, land-grant university recommendations on depth and spacing. So risk reduction is critical for these landowners. You know yourselves, they'll adopt new technologies and accept change, but they want to be pretty certain that there is a minimum amount of risk and a significant upside associated with it. Here's a chart from Ohio that shows top line sub-irrigation yields, bottom line drainage only, and there are huge differences there. We always figure ballpark 30% yield enhancement with drainage over undrained, unpoorly drained soils, and then another 30 to 35% as an average with sub-irrigation. And you can see that in some years it's much more significant than that. And typically when those low yields occur are when commodity prices are higher. So not only does that landowner or producer get additional yield, he has the benefit of higher commodity prices. So that can be really significant for them. Risk reductions, big issue. In addition to infield practices, drainage, water management, and sub-irrigation, Jane talked about these practices as well. If we design these systems correctly and we take into consideration all the potential upside from the environmental aspect, we can build in these saturated buffers and bioreactors to treat the water that we do release. So we release a minimum amount that we can, back to the golden rule of drainage, but what we do release, we try to treat for environmental benefits. So I mentioned that we talk a little bit about products. AgriDrain Corp manufactures and distributes top left manual water level control structures that are nothing more than a PVC constructed opening or a box with anodized aluminum extrusions for the corners. We have internal tracks in the system, and we have stop logs that you add into the tracks to raise and lower the water level. Very simple, affordable, long life, durable product. And these meet NRCS requirements for financial assistance. We do also offer several versions of automatic water level control structures with either locally programmable timer and switch to open and close on demand. So we can manage these systems seasonally. We can have 2-level or 3-level structures with single or 2 slide gate valves, and with those, again, they can be locally programmable, so they're low cost, but they convert that managed drainage system from full depth to medium depth when you close the bottom valve and open a middle valve. And then with both valves closed for the fallow season, you have the traditional drainage water management that maybe 6 to 12 inches below water level to maintain the storage in the field, reduce nutrient loss. Below that, you see we have water gate that is a float-operated, fully buried, automatic water level control structure that operates based on pressure differential. So that these units have been designed and built to where they have 2 floats in the barrel of the water gate itself. So when you back up a minimum of 12 inches of water on the downstream side, the floats come up and the plate on the upstream side goes closed, and the pressure differential will hold an additional 12 inches of water on the upstream side over the water level on the downstream side. But then it's infinitely variable. So if you have 2 feet on the downstream side, 2 feet of water, you'll have 3 feet on the upstream side. But then when the upstream side exceeds that amount, the weight of the water will overcome the buoyancy of the floats, and it will continue to flow. So it doesn't stop the flow, it just manages the flow. And this allows us to hold down the cost of the structure, the system. It allows us not to have to manage these things. And maybe more importantly, the farmer doesn't have to farm around these structures. So it gives us more flexibility in designing these systems. So we can put mains and submains in the field where a farmer can farm right over them. With our automatic structures, we also have two-way telemetry if we want to go that route, and not only can control water levels and flow rates, we go full gravity flow during drainage times. We hold water back when it's available, and we can do drainage water management. And then when there is a deficit, we can actually use these systems to manage variable frequency drives on pumps and open and close valves on manifolds to deliver water back into those subsurface drainage systems for full sub-irrigation mode. So we've got a lot of options, a lot of things we can do. And so I guess that's the end of my presentation, and happy to try to field any questions folks might have, and just appreciate your time.
Great. I would like to thank Charlie and Jane at this time for sharing the valuable information with us today. We do have some time for Q&A, so please enter your questions into the question box on your screen. And I do have a couple to get us going. So the first question, I guess this could be for either Charlie or Jane. If you create ponds for drainage control, how do you avoid the DEC deciding that your pond is a wetland and must be protected from agricultural runoff?
Okay, this is Jane, and I haven't had that specific question before, but let me answer a related question, which is what many people have related to wetland regulations. And if you are creating a pond in a place that could be considered a wetland, what we would recommend is that you have a wetland determination before that to show that it's not considered a wetland, right? So that it's dry land. Then when you create a wetland, it still is exempt from the Clean Water Act because there is a specific exemption for agricultural ponds. So we've had some question about whether they're all exempt, but what we know for sure is if it's created in a place that's not a wetland, then it's still not exempt. So whether are there DEC regulations to prevent runoff? I don't think there are into anything. We have a lot of runoff into all our ponds. So the regulation that I'm thinking of is the one that you wouldn't be able to drain it sometime later. There would be, obviously, it wouldn't make sense to say this is going to be protected from agricultural runoff because the whole point of the pond is to store agricultural runoff. So I'd be glad to talk to anyone about that. We have spent some time talking with both state and federal agencies, people at EPA, about this pond and wetland question, and we're confident that as long as it's created in an area that's not a wetland, there wouldn't be any problematic rules.
Okay, the next question. Have you reviewed any research by the University of Minnesota Extension on treatment cubes of iron filings, concrete, and other products to remove nitrates?
Okay, I guess I should probably answer that too. I don't know about the cubes. I'm guessing since the person put iron filings in the question that they actually mean phosphorus treatment removal structures. And there's, I have colleagues here that work on them. I don't work on them, but it is certainly possible to remove phosphorus from water, but it's just very expensive. It's possible to remove nitrate from water in something similar that are usually made with wood chips instead. So wood chip denitrifying bioreactors are more cost effective because it's not as expensive to get wood chips as to get iron filings. So in much of the region where nitrate is a particular issue, and it's especially in the Mississippi River Basin where nitrate in the Gulf of Mexico is such an issue, that people have looked at the denitrifying bioreactors, typically with wood chips. But it's possible to do it to remove some phosphorus, but just extremely expensive. So a lot better if we can keep the phosphorus out of the streams in the first place.
So the next question, are the technical service providers designing water management control systems, placements, PEs?
Charlie, will you speak to that one?
Yeah, be happy to. Some states do require that an NRCS approved plan is actually signed off by a PE, and in some cases, survey work is required to be done by a PE or at least signed off by it. Oftentimes, we'll just use LIDAR to take a look at a site to see if it's suitable. The first thing we do if a producer or landowner comes to us and says, hey, do you think this field's appropriate for some of these kind of practices? We look at the soils, we look at the slopes with LIDAR, and make a determination based on that. And if there are PE requirements, we, of course, address that and adhere to those requirements. But not all places and not in all times.
Okay. Can you put the flow level control box onto existing clay tile and not have blowouts where the tile can separate?
Jane, you want me to take that or you want to go?
Yes, if you have an opinion on that, that'd be great.
Sure. We get that question a lot because people are worried that those lines may have broken tile or there may not be as good a condition as what the newer installations are. What we tell them is that the pressure that you create underground is equal on both the inside and the outside of the tile. And so it doesn't really create any problems associated with that. If you have an existing broken tile and you open up a water level control structure and drain that water down rapidly, you could see maybe a blowout or a spot where soil is taken away from the farm field, and it's potential for that to happen. But as far as the clay tile is concerned, it's a question we get a lot, and it's not been a problem.
Okay. So next question. What can I do if my tiled field has no ditches or outlets?
Well, that's a difficult question. I'm wondering, it usually is an impediment to installing tile drainage. I don't know what to say if there isn't one. Certainly, the lack of outlet is a primary issue, that prevents more drainage. There's some work with pump drainage systems. They have a lot of them in North Dakota, and I think some in Ohio and Indiana becoming more common, where we don't have a gravity outlet and then we actually have to put in a pump. But Charlie, do you have any thoughts about that?
No, that's correct, Jane. Pump outlets are pretty typical. I think about 25% of the pump outlets in the Red River Valley, because they have an outlet, but the outlet or the ditch bottom, the flow line, is actually higher in elevation than the flow line of the subsurface system, the drainage system. And so the nice thing about that is you have a system that can be managed, because you just basically put in float controls on your pumps and you determine when you want to remove water and to what level. So you kind of really have a ready-made drainage water management system in that case. And then if you have an additional water source, you can pump water back into that system on the upstream side and control the pumps with that shutoff as well. So you introduce water into and you exit water out of via a pump.
Now, I should add that one thing we're looking at is, could a pond serve as an outlet where there isn't a good outlet? And I don't have the study yet. We're just studying on one site here where we have a problem of a lack of a decent outlet due to a railroad and a road. And so what we're thinking is that most of the water could go into a pond. We obviously have to design for an overflow because that's how hydrology is. You always will have more water than you plan for. The hurricanes recently show us that. But in those emergency times, maybe it could outlet into a road ditch or something like that. So it seems like it's a possibility to have the ponds that I talked about, the drainage water recycling ponds, solving this issue of lack of a good outlet, but we're not sure yet.
Okay. So is there any information on the impacts of controlled drainage on soil biology?
I believe that at this point, there still has been no studies that have shown any problems. It's unlikely to improve soil biology, unfortunately, but we also think it's unlikely to harm it. The soil biologists in our group have found no evidence. They've looked at earthworms and other parts of the biota and at least haven't found any evidence of problems.
Okay. So how much do we know about adjusting agronomic recommendations for fields with controlled drainage?
There, I think the agronomists are still cautious that we don't. There is some nitrogen that won't be lost, but whether it's enough to change the recommendations is still pretty uncertain. So I haven't heard any recommendations to actually reduce the nitrogen that would be input. But it seems like it might be a possibility, but there isn't enough evidence to show that could be. Now, the other practice that I talked about with drainage water recycling, there should be, because you're much more directly reapplying that water with the nitrogen and phosphorus in it to your land. So you know how much is going in, and you certainly could adjust your recommendations with that practice. But that's, again, a very new practice.
Okay. So what type of complications have you witnessed from installation?
Charlie, do you want to talk about that?
We find that our drainage contractors are really good at installation if they understand, and many of them do, most all of them do, what's required. They're good about it. They're careful. Normally, they're local guys who want to do the best job they possibly can because they're working for their neighbors or friends, and so we don't see a lot of problems. Occasionally, if soils are extremely wet and they plow them in, sometimes you'll have smearing along the sides of the ditch, things like that. That can be an issue. Once in a while, a structure may be over compacted by getting heavy equipment near it, and so they want to make sure they don't damage that. But for the most part, we've had really good success with professional contractors doing really first-rate installations.
Okay, and I think we have time for one last question. So other than the occasional gate adjustments, is there any other maintenance that needs to be done?
Oh, on the structures themselves?
Yeah.
We have been building this type of structure for probably over 30 years now, and we really marvel at how durable and long life they've been. We expected to see some significant issues initially because many of these are actually used in surface water applications as well, so they're subjected to a pretty harsh environment. We have them up in Canada, so extreme heat, extreme cold. We haven't had a problem except occasionally with continued use, you'll have some of the O-rings on the stop logs can become worn or tear off, and this can be easily replaced or new stop logs made available to them. But periodic lubrication with some additional grease we send, that's easy to remedy that situation. With automation, I guess it's like anything else. You know, we can have pressure transducers go down, we can have solar cells die, we can have battery issues with extended periods of clouds and things, but that's more an operational maintenance thing that you just kind of expect. And our producer customers are really good about that because they work with so much equipment out there that oftentimes they'll have a fully equipped shop and really well qualified people to maintain this stuff. So we've actually been quite surprised at how bulletproof a lot of this stuff has been.
And I'll just add that though the person said besides adjusting the boards, that is in fact a critical part of having of controlled drainage, and if drainage water recycling is considered as well. If the drainage water structures are installed but then not the outlet isn't moved up during the non-growing season, during the winter, there really is no purpose to it. So it is very critical that people get out there and make the changes. So I think it's a mind shift, because drainage has been typically something that people don't have to manage, right? They just put it in and then forget it. And so this is a change in mindset to something that you would actually need to manage and maintain, but then potentially have greater benefits from this system.
Good point.
Okay, great. Well, in the interest of time, I'd like to wrap up the Q&A. I really want to thank Jane and Charlie for joining us today. We really appreciate them taking the time to share their work. So thank you, guys.
Thank you. Pleasure.
So at this time, I want to recognize our participating egg retailers. If you're an egg retailer in the Great Lakes Basin that is interested in participating in our partnership to benefit your business and water quality, please contact our outreach coordinator, Caitlin Leahy, at caitlin@partnershipfarm.org. And finally, I'd like to acknowledge our funders and collaborators that made this webinar possible. In particular, the support from the Great Lakes Protection Fund and the National Fish and Wildlife Foundation. So as we wrap up, please remember to look for the email later this afternoon with a webinar evaluation, webinar recording, and a link to submit your CCA credentials to earn the 1.5 CCA CEUs if you've not already done so during registration. I want to thank you all again for joining us today, and I hope you will join us again for the next webinar in January. Thank you.